Okay, so let's start by adding logs with the same base. Pretty much any time in any problem you see multiple logs, you want to try to combine them if you can, okay? And you can combine them if they have the same base. So when you're adding two logs with the same base, you can combine them into one log like so, okay? And the contents of the log are going to be x times y. Okay, so when you're adding two logs, you multiply the contents. It's kind of similar if you think about, say, x to the second times x to the third. Well, we have the same base here, right? And we would add because we'd have 5 total x's multiplied together, so you could add the exponents. So multiplication and addition go hand in hand with a problem like this, but also with logs, okay? When we're subtracting, you got to have the same base to make this work, but hey, we do have the same base here. It's base b. Instead of multiplying when we're subtracting, we're going to divide. Okay, so you could write x divided by y, but it's usually written as a fraction like that. And it's a good idea to use parentheses, especially here, because sometimes it's kind of confusing. It's hard to tell. Sometimes the y looks like it might be part of the base. And now it's really clear that I have the parentheses there. Okay. So some basic strategies for solving equations. These are for log equations, but you can really use this same strategy for exponential equations as well. So if you have multiple logs, you want to combine them. On these first two problems, I don't have multiple logs, so I'm going to skip that, right? On the next step, I would simplify as much as I can with old school algebra techniques. So I'd be looking for things like terms or fractions I can reduce, anything like that. On this problem, there's nothing, right? Because inside the log, they're not like terms, and there's nothing else I can do there. So I can't simplify. Actually, this one I can't either. So on both of these, the first step is going to be to convert to, this says convert to exponential or log form. I'm going to convert them to the form that they're not in. So I'm going to convert these both into exponential form since they're in log form. But if they're in exponential form, usually you'd want to convert them to log form, okay? So I need to solve for x, but x is trapped inside of the log right now. That's why I'm going to convert this, okay? So my base is 7. The isolated part in log form is the exponent, so that goes there. And then the contents of the log will go over here. And now I've freed the x, it's not stuck inside the log anymore, and now I can solve for x, right? I just need to find 7 to the third, which is 343. And then I just have to subtract 3, and after that divide by 5. And then x will come out to 68. Okay. All right, on this next problem, again, I'm going straight to the conversion step, the third step there. So my base is 2, the exponent is x, and then the contents are -4. You could actually, this particular problem, you could type this into your calculator, and I'll get to that in a second. But let's just think about this for a second. So you can think, we can kind of try to do this with mental math because I've just got a 2 and a -4 there. So I'm thinking 2 raised to some power equals -4. Well, okay, I know 2 to the second equals +4, right? So some people are going to say, oh, 2 to the -2 equals -4. But no, it doesn't. Because 2 to the -2 is 1 over 2 to the second, which is 1/4. So no matter what I put in for an exponent, it's going to come out positive. Or it'll always come out positive. Because if I raise it to a positive power, it's positive. If I raise it to a negative power, it's still going to come out positive when my base is positive. Even if I raise it to the 0th, anything to the 0th equals 1. So this is not going to work. So this x is going to be undefined, or you could say no solution. Okay? And that is going to happen every time the contents of a log are negative, because we're saying 2 raised to something equals -4. It's just not happening. So we could try this out in our calculator. Remember, with the change of base, this would be log of -4 over log of 2. Let's see, there we go. Log of -4, close the parentheses, divided by log of 2. And so, if I never tried this method and just type this into my calculator doesn't like that because it's not a real number. It says non-real answer, so it's undefined. or no solution would be fine too. Okay. All right, moving on. So actually, before we move on, it's always going to be fine undefined. When contents are negative, when contents of log are negative. Okay. All right, so anytime you see the contents of a log negative, you know that's going to be undefined. All right, so moving on. So these next two problems, I do have multiple logs, so we'd want to combine those first, okay? So I'm making sure they have the same base, and these are both the common logs. So remember, when there's no base written, it really means base 10, and you don't have to write the 10s in, but just reminding you that that's what that means, okay? So I can combine this into one log. I'll write the base of 10, but again, it's okay if you didn't. Now, when I'm adding here, so I'm thinking I'm going to multiply the contents of the logs together. And when you do that, don't forget to use parentheses because you're going to have to distribute that x. Okay, so it's not just x squared plus 9, it's x squared plus 9x. Okay, so I simplified in there a bit. There's no more like terms in there. So this third step again where I want to convert this because I want to solve for x, and I can't when the x's are stuck inside the log. So 10 to the first is going to equal x squared plus 9x. Okay, so 10 to the first is just 10, right? So hey, let's set this equal to 0. And then hopefully this is looking pretty familiar. This is a quadratic trinomial, which this one happens to be factorable, so let's factor it. Okay, so I'll use a diamond problem here, putting a 9 on top, a negative 10 on bottom. And I'm looking for two numbers that add to 9, the same two numbers multiply to negative 10. So I'm thinking negative 10, well, if I use a 1 and a 10, I can get to 9 if the 10 is positive and the 1 is negative, right? Those multiply to that, add to that, so that's my winning combo there. So this factors to x plus 10 times x minus 1. Okay, so zero product property, I've got two candidates here. X could equal negative 10 or x could equal 1, okay? But I still want to make sure, and actually you should really always do this, but especially when you get two solutions like you have here, often one of them is extraneous. They could both be extraneous or neither of them could be extraneous. But what I'm looking for is if I were to plug these two numbers into or either one of these into the original equation, would it make the contents of one of the logs negative? Okay, so when I'm plugging in negative 10, well, it actually makes both of these negative. So it makes both of them undefined. So that's going to be extraneous. I didn't leave myself much room, so I'm writing that there. This one, you got to throw it out because it does not work with the original equation. It makes those undefined. Okay? When I plug in a positive 1, I don't really need to think through what these pieces actually equal, but I'm just kind of spot checking. Yeah, those contents would be positive. So would these. So that one's good to go. Don't need to throw that one out. Okay? All right, let's try another. I got base 10 again here. So I can combine these. This time I'm subtracting. So remember that you're going to divide the contents. So there's the first contents divided by the second one. This equals 2. There's not much more simplifying. I can't do anything with that fraction right now. So let's convert this. 10 to the second is going to equal the fraction. Okay, so 10 to the second is 100. Okay, remember I'm trying to solve for x. So I want to think, well, how could I get the x by itself? I would start by multiplying both sides by 4. That'll clear the fraction. So 400 is going to equal 3x plus 1. Now I just subtract 1 from both sides up here. So 399 is going to equal 3x. And then divide by 3, so that's going to be 133, right? Okay, and just a real quick spot check. I don't have a variable there, so I know those contents are positive, and that's definitely going to be positive there too. So that's a good answer. Okay. All right, on to the next page. Okay, next up is something called the power rule, and this is going to be super useful in certain circumstances. So when we've got a log where the contents are raised to something, it doesn't have to be x, it could be anything. What I can do with this exponent is a little of this, like that. So I'm going to pull that x out in front of the log, and it's going to become a coefficient. So it's going to be x times the log, okay? And you can use this in reverse too, right? If you have a coefficient, I could pull it up there and make it an exponent. So you can use the power rule in either way. It's very powerful. All right. Okay, so this next problem, you actually don't need the power rule to solve this for x. You could say, okay, 4 to the 20th is going to equal x to the 5th. And I could definitely solve that. You know, I could take in my calculator 4 raised to the 20th, and then I'd end up taking the 5th root of that. Okay, nothing wrong with that, but this is going to become a little bit easier, quite a lot easier actually, if we use the power rule. So if I take this exponent and pull it out in front of the log, now I've got this, okay? And I wouldn't want to convert this as is because it's got a coefficient, but hey, I can get rid of that coefficient just by dividing the equation, the whole equation, by 5. Now I've got the log of 4x is going to equal 4. And now let's convert it, okay? So, you know, I could have converted at the beginning, but I just have larger numbers to deal with. Now this is simplified quite a bit. And when I convert this one, 4 raised to the 4th is going to equal x. Okay, and then 4 raised to the 4th comes out to 256. Okay, same exact thing you would get by using this technique, but it's just a little less work to do. It's easier to deal with the 5 just by pulling it out front than dividing by 5. Okay, and there are certain circumstances where you need to use the power rule, so it's very handy. Okay, all right. Logs with different bases cannot be combined, but also if logs have coefficients, like this log has a coefficient. So with logs with different bases or with coefficients, whether they're the same or different, can't be combined. Okay, so looking at this next, this says write as a single log. Now they have the same base, so that's good news, but the bad news is they have the coefficients. Okay, so we can combine these, but we have to mess with them first and get rid of those coefficients. Okay, so what I want to do is use the power rule. I'm going to change that 3 into an exponent. I'm going to change the 2 into an exponent. So now I'm going to have log base 2 of 5 to the 3rd plus log base 2 of 6 to the 2nd. Okay? Now I can combine these. Okay, and you have an option. You could simplify 5 to the 3rd and 6 to the 2nd right now if you wanted to, or you could do it later. It really doesn't matter. You just want to do that at some point in the problem. So when I combine these logs, since I'm adding the 2 logs together with the same base, I'm going to multiply the contents. Okay, so you can see it doesn't really matter if I'm going to simplify that at some point, right? So let's see, 5 to the 3rd is going to be 125, and 6 squared is 36. And then 125 times 36 is 4,500. Okay, and I've combined this into one log and I've simplified. Now, I could actually evaluate that in my calculator. It'd be a log of 4,500 over log of 2. But this didn't ask me to do this. It's just asked me to write this as a single logarithm. Okay, but I could figure out 2 raised to some power equals 4,500 with my calculator. Okay, all right, same kind of deal here. So before I combine these, got to move that 4. I'm using the power rule. Now I can multiply the contents together to combine this into a single log. Okay, so it's going to be x to the 4th times 5. Well, I'm going to write that as 5x to the 4th. Okay, now be careful that the 5 isn't raised to the 4th power, only the x is, right? If you were to write this, this would be incorrect. You don't want to do this, but this is what I see often, is that people will do something like this. But that's different, right? That means the quantity 5x is raised to the 4th. Only the x is raised to the 4th. The 5 is not raised to the 4th, so this is incorrect. Okay? So there's really nothing else I can do with this. I mean, I've combined it into a single log. I don't know what x equals either, so there's no simplifying I can do. Okay? All right. So one more here. So I see, oh, we've got a coefficient. Let's move that out of the way. The second log doesn't have a coefficient. Okay, and then since this is subtraction, I'm going to divide the contents when I combine. And can't simplify the fraction anymore, so this is good to go. Okay, next page. So this asks me to simplify this, and looking at this logarithm, there's no exponents here. It's a little weird. We've got a log that's all contained in an exponent, but you know, I could use my calculator to simplify log of 17, or log base 3 of 17. It would be log of 17 over log of 3. Okay, so let me go ahead and do that on my calculator. That would be using change of base formula. I'm going to write it like this, okay? And then I've got that decimal there, okay? I'm just going to keep that decimal in my calculator for further use, but this would be about equal to 3 to the 2.58, okay? Now, I could take 3 and raise it to that. I'm going to use my calculator. I'm raising, and then I'm going to hit second negative, so I don't have to retype that whole, then it will reuse that whole decimal I've already got there. So the second negative button. So 3 raised to the last answer. Oh, and this comes out to 17. So I'm pretty sure it's actually exactly 17, but even this number is rounded, right? It only goes so many decimals. So, all right, so there we go. All right, now let's look for a little pattern here. You might notice, wait a sec, hey, there was a 17 in the original expression here. And that's actually not a coincidence. You also might notice I've got 2 different bases, really. I've got the base of the exponent, which is the 3, and then I've got the base of the log, and it's also 3. Hey, I got the same base twice, okay? So let's just keep that in mind. I'm going to solve the next one. Well, actually, no, I'll stick with this one. So let's look at this in a different way. Let's say I had... I have an expression now, but let's make this into an equation, okay? So I want to figure out what this equals. I feel like my camera is not focused. I'm trying to focus it there. Okay, so let's make an equation out of this. I got to figure out what this equals. So I could say x, but I'm just going to use a blank. I got to figure out that equals something, okay? Now let's convert this in, this is an exponent here, so let's convert this into log form, this whole equation, okay? So if I convert this into log form, I've got log. Now my base is 3, okay? The exponent from coming out of an exponential form is going to get isolated. So, you know, this whole thing is the exponent, right? Okay? And then my empty box would go right here. And now looking at this, just looking at it, well, to make this work out, I need both sides of this to be the same, so the contents of the 2 logs have to be the same. So that means this equals 17, right? So that means, if I go back up, that's 17. So that's 17. So there's a nice little shortcut here, okay? When you've got a number that's raised to a log and both of the bases are the same, like over here, well, then this is just going to equal 17, right? This problem is the same as the previous one, except instead of 3's, I had x's. But, anytime you have a problem like this, say I had 8 log base of 8 to the 29, well, I'm noticing, oh, got those two match up, and so this is going to equal 29. You could use, that's a new example there. You could use, this method, but it's a nice little shortcut, okay? Now, there's one problem with the shortcut, and that problem is if you have a coefficient in the log, then that's kind of in the way. That's going to cause a little problem. But we got a way around that, because when I have a coefficient of a log, I can use the power rule. So when that happens, just do this, okay? And now we can use that shortcut. So just like the previous problem, I've got the same base twice. So this is going to be equal to just the contents of the log. And the contents of the log is 7 to the second, which is 49. Don't even need a calculator for that, right? Okay. All right. So I guess this kind of goes with the way I was showing this up here. But when you have two logs with the same base that are equal on both sides, and that's all you have on two sides of an equation. Excuse the bell there. Hang on one second. The contents of the logs are going to be equal. So yeah, we could combine these two logs. I could subtract one of the logs from both sides, set it equal to 0, start converting it. But if you have two logs that are equal and they have the same base and there's no coefficients or anything in there, I know those are going to be equal, right? So that allows me in one step to say that x is going to equal 7. So, take the easy way if sometimes there are multiple ways you can do these, okay? All right. Next one, I see I've got two logs, and there is something else going on. I can't just set these equal to each other, right, because the 2's in there. But I can combine these. Remember, these are my common logs, so the base is 10. You don't have to write it in, but you have to know that's what it is, okay? So log base 10, and then I'm going to be multiplying my contents together. Okay, let's simplify that a little bit. That would be 50x over 2, or just 25x, right? If I simplify this, and I guess you don't need the parentheses there, but I already wrote them in. Okay, and now there's not much simplifying I can do, so I'm going to convert this. So 10 to the second is going to equal 25x. 10 to the second is 100. Then I just divide by 25, and x is going to equal 4. Okay, and really should do a little spot check to make sure in the original problem I don't have like negative contents to a log, but yeah, I'm good there, right? So that's a good one. Okay, so next up, base 10 again, and I'm adding again, so let's combine the two logs. So it's going to be x times the quantity, x plus 48. Don't forget those parentheses because we're going to have to distribute the x there. Okay, it is important to have parentheses here to show that the 48x is part of the contents of the log. Otherwise, it would be unclear. Actually, if there weren't parentheses, I'd think the x squared is the contents, but the 48x is not. It's just added outside of the log. Okay, so here we go. No more simplifying to do. So let's convert. So 10 to the second is going to equal x squared plus 48x. Okay, that's 100. And let's set this equal to 0, and I'm going to have a quadratic equation here that hopefully I can factor. And if I couldn't factor it, I could always complete the square quadratic formula. Okay, so let's try this one out. This one actually is factorable. I'm going to use a diamond problem here. Okay, so I'm thinking, all right, adding to get 48, multiplying to get 100. So 100, I'm thinking multiplication, first thing that pops in my head is 10 times 10, but I can't get 48 out of two tens. So I got to think of something else. So 5 and 20, no. 4 and 25, no. If you keep playing around with it, 2 and 50 would work, right? 2 times 50 is 100, and hey, I can get a 48 out of a 2 and a 50 if the 2 is negative and the 50 is positive. So there's my winning combo there. Okay, next up, zero product property. One of these two things has to equal 0, so that means x would either equal 2 or x would equal negative 50. This is raising my suspicions. I'm not going to throw it out just because it's negative, but if it makes one of the contents of the logs in the original problem negative, then I'll throw it out. Okay, so it is possible to get negative x values. It's just you don't want contents of logs. And hey, that's not going to work right there or right here, right? Either place, that's a no-go. Although the positive 2 is not going to make those contents negative in either case. So the 2 works, but the negative 50 was extraneous there. Okay, let's try another here. So again, I want to combine these logs, but before I do, hopefully that catches your attention. You can't combine them because there's just nowhere to put the 2 in this format, well, this 2 at least. So I want to rewrite this as log base 2 of x squared plus log base 2 of 5 equals 7. Okay, now I can combine. So I'm going to multiply the contents together. That would give me 5x squared. That's my contents. That equals 7. Okay, so now I can convert this. 2 to the 7th is going to equal 5x squared. Let's see. 2 to the 7th is going to come out to 128. Okay, I'll divide by 5 next. Not really fully showing all of my work because I'm running out of space. Oops, I'm off screen too. Sorry, there we go. There's 128 divided by 5, gives me 25.6. Now I take the square root of both sides, and don't forget when you do that, should be taking the positive and negative square root of 25.6. Use my calculator for that. And it's going to give me a long decimal. I'm going to round this to the nearest hundred, so I'll call that 5.06. Okay, but hang on. Negative 5.06 is no good here, right? Makes the contents there negative, so I'm going to throw it out. So actually, I'm only going to use the positive one. So a lot of times the negative x values are extraneous. Not always, that's not a solid rule, but you be on the lookout for that. Okay. All right, this one, there's a little bit of simplifying. I can simplify the fraction. I mean, I could convert it right now, but it's easier if you simplify the fraction first, or simplify anything before converting. So 3 over 12 is 1 over 4, right? So this gives me x squared over 4, okay? And now my base here is 10, so 10 to the second is going to equal the fraction. 10 to the second is 100. Okay, multiply both sides by 4 to isolate the x squared, and that means 400 equals x squared. Okay, and then when I take the square root of both sides, x could equal positive 20 or negative 20, right? 20 is the square root of 400. But then I'm looking at the original. Now on this one, if I plug in a negative 20, it's actually okay, because when I plug in a negative 20 here, I'm going to square it, and it's going to come out positive. So that negative 20 is not going to make the contents of the log negative, so I don't have to throw that one out. So that's why I put this one on here, is because I wanted to show you don't throw out the negative automatically. Check if it makes the contents of the log in the original problem negative or not. Okay, and that is it for today. See you next time.